efficiency?
Efficiency.
Good afternoon, everyone. Respected Head Department of CS&IT, Professor Pradeep Kumar sir, and respected faculty members and dear participants. It's my pleasure to welcome you all to this afternoon session. We are honored to have with us today's resource person, that is Mohammed Sibgathullah. Mohammed Sibgathullah sir is highly proficient and resourceful individual who has made significant contribution to their field of work, that is in automotives. Sir is highly accomplished industrial automation specialist with 13 years of experience and expertise in utilizing cutting-edge tools for assembly manufacturing program and robotic engineering. He completed his graduation Bachelor of Science in Mechanical Engineering from Mufakam Jah College of Engineering and Technology, OU in 2010. He has many practical skills like AR, VR, Team Center, VSMOKUP, Process Simulate, etc. and also hold many certifications like AICTE 101 Ford Ergonomic Design Thinking Crash Course, Mean Manufacturing Certification and Conflict Management. Sir has implemented many tools like Team Center, MPP, VSMOKUP, Process Simulate and RopeCat, which tends to optimizing the production efficiency by 15%. He has worked as virtual assembly engineer in Axis Gates Company, Hyderabad from 2010 to 2012, where he is assisted industrial engineering with data analysis, process documentation, and contributed to the successful implementation of Plex for optimized manufacturing. And right now, he is working as a senior specialist in virtual assembly Ford Motor Company, Chennai, Tamil Nadu. Sir leads automation projects and manages a team of engineers to design, simulate and implement robotic paint sealer systems in the manufacturing facilities. So we are excited to learn from his vast knowledge and experience. And once again, welcome to the sir. We are grateful for your presence here today and look forward to hearing from you. Welcome you, sir. The dais is over to you. Assalamu alaikum, everyone. So, how was the morning session?
Good.
See, we are very tired.
It was powerful.
So, we'll take it, we'll cut short this as much as possible. For your convenience, so that you can grasp much more than what you have grasped. If it's a longer session, then it will be taken.
It was based on NLP.
Okay. This is more interesting. If it's more interesting, we'll go ahead. Okay, we'll keep going. We'll see how is the response from the team, or the students. Okay, so the topic which I have been given is quantum transfer learning in industrial automation. So, any idea in industrial automation what we are, where we are, what we are doing? Anybody? Industry 1, 2, 3, 4, anything about that? AIML, I think we have covered something in AIML, isn't it? Have we? In automobile or any other industry? What the industrial automation has? No?
They are using various emerging technologies like predictive maintenance and use of sensor networks to operate the machine to automatize them.
Okay.
In the medical field?
Medical field.
Smart healthcare system, smart industry.
Smart industry. Okay. Anything from the other side? Smart vehicles.
Smart vehicles.
Smart vehicles. So basically, industrial automation as a terminology is we want to automate the industry to the use of IT. Alright, in short, I'm talking about. So, industrial automation is nothing but, by definition, it's using the
control unit, the machinery and the IT to get the maximum efficiency from the plant, or maximum efficiency and enhance productivity and consistency in manufacturing process. So what happens if we don't have these, then we will not be getting the product in the right time. So go for the next one. So we'll see how we have evolved in manufacturing. So I see we don't have much knowledge on the industry 1, 2, 3, 4, where we are standing now. So this is more or less related to the mechanical perspective. So we started with industry 1.0. First we had the industrialization revolution in mechanization and steam power. So we used to have, this is in early 1914s and something, alright. So we started with first industrial revolution, we had trains, steam engines and everything over there going on. And we evolved from there to the second industrial revolution that had to do with mass production, and then oil and electrical machines came into the picture. So with the help of that one, we were producing the vehicles or any other manufacturing parts with the help of oil and electrical machines and with mass production. Okay. So as we move forward in 1970s, we had a third industrial revolution. That was we introduced the robots. So still we are using that, but in industry 3.0 we started using these robots. Alright, so this is clear. So this is how we have evolved from 1, 2 and then 3. And then from right now what we are having is industry 4.0, which I believe most of that is connected to the IT related thing. So this is the technologies that we are using in the manufacturing process. The Internet of Things, Big Data Analytics, AI and ML, and additive manufacturing, cloud computing, robotics and automation, digital twin, AR and VR. Alright. I think AI and ML we have already covered in this week. In the starting session it was about AI and ML. And Internet of Things, Big Data Analytics, so all these are interconnected to each other. So the idea behind using all these things is to enhance the productivity and make the manufacturing process more efficient, effective. Alright?
Yes, sir.
We still have someone coming in?
Yeah.
Yes, sir.
Shall we wait
The
for
last session was.
No, you just continue.
Okay.
Continue,
Yes,
sir.
okay. Okay. So these are a couple of digital technologies which we are using right now, currently in our industry 4.0, and these are being utilized in across the industries, whether it's on automotive or aerospace, aviation, wherever you go, where there is a mass production and there is a want of a product with bulk manufacturing process. Alright, so we'll see a couple of them, how we have used, how we have utilized them to get the output and to use of the industrial automation in industry 4.0 with a smart factory and cyber-physical systems. Okay, so this is this slide gives us, the evolution of how we have been building the manufacturing process, how we are design to build, how we have been doing from 2D to 3D, how we have evolved, and from there how we are actually identifying and defining, redefining and making the manufacturing ease with the help of a digital era. So we have in 80s we used to use 2D layouts, 2D drawings and all. We used to have sheets wherein, or the AutoCAD layouts you can say, in today's era. So in 80s we used to have that, and we used to do the 2D layouts and draw those drawings, and then it used to go to the manufacturing team. They used to validate that in the shop floor with a sample prototype, and then that has to go through the manufacturing feasibility with the tooling fixtures and everything, whether how much it's feasible to manufacture the product. So these things stopped in almost 90s, where we had introduced the software called as CATIA Solvers. I think 3D modeling softwares which I use for modeling CAD. So where we used to model the CAD and analyze in there itself, where we have a finite element analysis, stress analysis, strain analysis, and all those things we used to do in 90s and 2000s. And by the time we reached 2006, we had manufacturing feasibility analysis tools as well available. Like in the picture you can see that's WIS mockup, digital mockup, where we can actually do the manufacturing feasibility. In the sense, we will be able to, digitally, we can place the CAD on the shop floor and check whether how much feasibility is with the tools, with the fixtures, with the human, how much we are able to assemble that, how much we are able to manufacture that, whether it's feasible or not. With me? Yeah?
Yeah.
Still with me? Okay. I'll keep checking. Okay. So, digital tools that are being used is nothing but digital manufacturing. So we are trying to use the computer system and automation technology. That's what is the digital manufacturing. Alright, and what does it involve? It involves the various technologies such as 3D printing, CAD/CAM, robotics, and data analytics. So with this one, we are trying to achieve maximum output, greater efficiency, and consistency in manufacturing. So how these things are theories. I believe you know, if you go for some research, you will definitely get all these things: digital manufacturing, industrial automation. So how we are actually incorporating all these things into the industry, and how it's actually reflecting that on us, is we are going to see in the next slides. Okay. So all these things which we have discussed so far, it's all the key components of the Industry 4.0 or IoT in manufacturing, you could say. Okay. So this is the digital manufacturing where it fits. So what happens is, if you want to build a car, for example, and you have a design. In earlier days, back in 2000, you could say. So if I had a design and want to manufacture that car, it used to take a lot of time, almost around 5 years or something, because you have to go through design and then analysis, and then it has to go through manufacturability, then it has to go to the production, and then in production you will have to go to the setup, plant layout, everything, all those things has to be done. So it used to take how much? Around 5 years to 6 years it used to take. And so for that reason, when you used to go to buy a vehicle, they give you a wait time for it, isn't it? So earlier it used to be a very high wait time. Now they have reduced that. And that's thanks to the digital manufacturing, where we can actually manufacture in a lesser period of time, and we can get the output much more faster than what it was before. Okay. Alright, so in this one, what we are trying to see here is with the help of PLM solution, I believe we have a product lifecycle management subject. Do we have that? PLM? Anybody? PLM? No, we don't have PLM.
Real, sir.
PLM, product lifecycle management. No, we don't. So product lifecycle management is nothing but revolves around scratch of the product till the manufacturability. That's what is the process going on in there, whether it's going to be a product research, design, planning, workflow, design of the tools, fixtures, or obtain and operate the factory operations, everything. So this is an end-to-end solutions where you will have the product design, from design till manufacturing. Job one, you could say that. So how we are connecting this one with the IT is the thing. Otherwise, anybody here know BOM?
Which bomb?
BOM. B-O-M. Not B-O-M-B. BOM. This is a bill of materials. Bill of material is nothing parts that we can see inside any product. If it's a keyboard, then bill of materials would be the buttons, the back cover, the front cover, all the parts including in there. That's called as a bill of materials. So managing the bill of materials inside of PLM and through end to end from scratch to that one will have certain time. So if you're talking about, let's say 10 years back, it used to take 5 years, as I said, to manufacture a car. Digitally they used to take around 2 to 3 years, because you have to design that, and then you have to take it to the next software, and then you have to take it to the other software for analysis. So PLM is a suite that actually gives us in one platform, it does everything. So it does your design, it does your feasibility analysis, your design analysis, your process planning, your workflow analysis, everything comes in one platform. So with this one we are able to actually achieve 50% reduction so far from 10 years till now. So, so this happened because of the use of the PLM technology or the PLM software or the suite, you could say, where we can do digital manufacturing, production, process design and virtual factory simulations. Okay. So how we are going to do this, how we did this, we are going to see in the next slides. Alright. So just remember these slides, so it will be easy for us to connect when we get to practical. So as we have already seen, like what we are able to do in digital manufacturing is high-level process, manufacturing process and process planning, work instructions for the operators, details process design, 3D factory layout, equipment tool and fixture simulation, ergonomic simulation, validation and virtual commissioning. So these are all what we do in this one, and we'll see how this goes. Alright, so this is more or less how our factory looks like. Okay, so you can see there are some men who are actually fitting the tire of the car, and some robots are there. They're actually assembling or welding in there. Alright, and there's a door. So this is the factory, how typically it looks like. Okay, on a 2D scale. And this is a Team Center software, which I will just show you how we are. Able to see this. We can begin?
Yeah.